Okay, this is part 2 of a review for the test. We're having a test tomorrow. So, if you want a decent review, please make sure that you study part 1 as well, which was classwork today, as well as part 2. Also, the previous video was review C, and so you really need to put all this information together for a more thorough review. Do not think that this is a comprehensive. This review does not cover every little thing that's going to be on the test. Okay, so if you really want to be thorough, this is day 9. You want to go back and look at the classwork and homework from day 1, day 2, day 3, day 4, day 5, day 6, day 7, day 8, as well as day 9. All right, because it's all up in there. Okay, so here we go. If you have not read this problem yet, just pause the video and read the problem. I feel silly reading the problem to you, so I'm not going to do that. So pause the video and read the problem for a minute. Okay, so hopefully you read the problem by now. So, was this an experiment or an observational study? This was an observational study. Alright, this is an observational study because Miss Mercer did not assign certain kids to do homework and assign other kids to not do homework. She did not choose who's doing homework and who's not doing their homework. She simply took note of, oh, here's some kids that were already doing their homework. Let me see how they do. Here's some kids that weren't doing their homework. Let's see how they do. So she did not interfere with what they were doing in any way. All right. She did not determine who did homework. All right, now, what is the explanatory variable? Remember, the explanatory variable is the thing that comes first, okay? The response variable is the thing that happens later. So we are trying to, she's trying to figure out the relationship between students doing homework, okay? That's the explanatory variable. And test performance, that's the response variable. Okay, so she's observing, do kids do their homework, and she's observing what effect that has on test performance. So it's like cause, it's a potential cause and the potential result, possible result. So I already answered the question. So the explanatory variable is homework completion. And the response variable is test performance. Okay. Name one or more lurking variables that could influence the mean test scores of the two groups other than the percentage of homework they completed. Okay, again, when we're talking about lurking variables, you should be thinking of things that that could cause the test performance to be different, other than whether or not they did their homework. And in fact, sometimes ask yourself this: all these kids that didn't do their homework, why didn't they do their homework? Okay, and the answer to that question, whatever is causing them not to do their homework, might also be affecting their test scores. Okay, that might be the real reason. Okay, for their test scores. For example, now these are just hypothetical, but imagine that that a student has a job. Okay, all right. Let me just write that down. Maybe, all right, student has a job. Okay, what if a student has a job? That because they don't have a job, they're not doing their homework. Okay, but also because they have a job, they're not studying. Okay, also because they have a job, they're not getting enough sleep. They're tired. They're not paying attention in class. Because they have a job, they're sleepy all the time, and as a result, their test scores are going down. So maybe the job is causing them not to do their homework and have bad test scores. So the homework might not be causing the bad test scores. It might be the job. Okay. Now, job was just one specific example, but in general, we could just call it extracurricular activities. All right, and that could include sports, clubs, having a job, all of these types of things. Let's see, what else? Yeah, another possible lurking variable is like aptitude, and I'm kind of hinting at intelligence. Okay. Whoops. Think about it. Imagine that somebody is just really bad at math. Okay, it's a struggle for them. It's difficult for them. They have a low aptitude for math. Then obviously having just a low aptitude for math in the first place, those kids are gonna do more poorly on tests, okay, just because they're really bad at math. But also, do you think that might have an effect on how much homework they do? If math is really easy for you and you can just sit down and knock it out easily, then you might do more homework than someone who, to do their homework, it's a painful struggle. So they're likely to do less homework. But it might not be the homework, the lack of homework that's leading to low test scores. It might be a low aptitude and low intelligence, frankly, that's leading both to the low homework and the low test scores. So these are two examples of possible lurking variables, two big ones. There could be others. All right, number 5. Design and diagram a completely randomized experiment that would avoid the lurking variables above and better illustrate whether or not doing more homework is likely to improve student test scores. Okay? Yeah, the problem is that she put together a group of kids with low homework and then a group of kids with high homework. But accidentally, she might have a group of low aptitude kids and then a group of high aptitude kids. So that's not, when you look at those test scores, that might not tell you anything about whether or not homework helps you do better. It might just be reflecting the intelligence of your kids. Or she might have created, by picking grouping the kids who already had poor homework average, she might have a group of kids who have a bunch of extracurricular activities versus a group of kids who have plenty of extra time. So again, when we look at those test scores, even though we might see a difference, that difference might be because of the extracurricular activities. So we need to avoid these lurking variables. We can do that by randomizing, okay, in a way that she didn't. So instead of making a group out of low homework kids, we will just take all 150 kids and randomly assign them to two groups. All right, so the kids who normally don't do any homework, there'll be some of them in both groups. Okay, but then we won't give them a choice. And so the kids that normally do all their homework, some of them will be in the group who's going to be told not to do any homework. Okay, they'll be all mixed together instead of segregated like that. So here comes my design. Alright, so here would be your completely randomized experiment. 150 students randomly assigned into two groups. Alright, 75 each. And then you randomly decide whether or not group 1 gets the daily homework assignment or no homework. Alright? It won't automatically be group 1. It's not just going straight across. You have to switch it up and let the random number generator decide. And then we compare test scores between the two groups. That will tell you if homework is really helping students have higher test scores. All right? If it is, of course, those kids who normally don't do their homework, if they're in the daily homework group, you'd have to make sure that they're actually, you might have to sit down and almost like detention and make them do their homework. But I guess presumably you have to get kids willing to participate in the experiment. So if they get picked for the homework group, they're going to do it. Anyways, that's it for that. So number 6, who or what are the subjects of our new experiment? The subjects are the students. Plain and simple. That's it. Alright, what is the treatment, or what are the treatments? There are two treatments, daily homework and no homework. Okay, those are the two treatments. Kabam. What is the control group? Alright, the control group is whichever group gets no homework. We can't tell if it's group 1 or group 2 because it's going to be that's going to be randomly assigned. But the control group is always the group that doesn't get a treatment, or they get a placebo. Alright, so I'm just going to put the group that gets no homework. Okay, diagram a matched pairs version of the above experiment. Alright, so watch this. Please notice that if I want to rewrite this as a matched pairs experiment, first thing I'm going to do is cut and paste. Oh no, I lost it. I see. The first thing I'm going to do is cut and paste the completely randomized experiment because it's almost identical. Alright, I'm just going to make one or two small changes to make it matched pairs. Matched pairs is the type of experiment where each subject gets both treatments. So somehow we'd have to have a subject that did daily homework and then did not do daily homework. So probably in practical terms, the way you would do that is you'd have to have 2 units. So you'd have one unit where a student had homework assigned every day. And then you'd have another unit, a second unit, where no homework was assigned. And assuming that the units are very similar in level of difficulty. And then when you compare the test scores, you're not comparing between groups, you're comparing each individual to herself. So same kid you compare how she did in the unit where she had homework to how she herself did in the unit where she had no homework. And then you see if you can see a pattern. Anyway, in terms of the way you set up the diagram, all you really need to do is create an additional, you got to double up the treatment basically. So if they had the daily homework before, then this time they're going to have, the next time around they'll have no homework. Okay, so come on. Alright, I hope it doesn't crash right now. Alright, did it do it? No. Okay. So next time around we will have no homework. If we had no homework before, then the next time around we will have daily homework. Okay. And so that's the way it's going down. Let me just copy these real quick as well. Move those over here. Okay, and there you go. Alright, that's the main thing that you needed. Let me highlight this in blue to emphasize that all of this stuff over here is identical. You just saw me cut and paste it. But I had to double up the treatment, okay, so that each subject winds up doing both in a row. Now I have to make one other small change right here, so I might as well color this blue as well. Because if I just say compare test scores, again, that's going to look like I'm comparing group 1 to group 2. But no. I'm comparing same subject test scores, okay, like I described before. I'm comparing each individual with himself. So we just need to get that phrase in here. So instead of saying comparing test scores, I'm going to say compare same student test scores. Okay, I can barely fit it in my little window here. Yeah, compare same student test scores. So now that is a 100% matched pairs diagram. Okay, soak it in. So notice everything in red is exactly the same as the completely randomized. You just have to modify the end, add an extra repetition of the treatment, and change the wording on the comparing part, mentioning that it's the same subject, or same student, same rat, same tomato, whatever it is. All right, I talked too much. Let's move on. Okay, you want to compare 3 treatments for a certain type of cancer. The treatments are chemotherapy, radiation therapy, and drug therapy. You want to see how many subjects will have their cancer go into remission, okay, which is like almost like going away, but you still worry. So you want to see how many subjects will have their cancer go into remission after 3 months of treatment. We'll call that the rate of remission. You have 200 patients willing to participate in this experiment. So first we want a completely randomized design. So to make my life easy, I'm going to cut and paste from my last randomized design and just change the words. Shimon Lee, Shimon. Alright, I'm going to do this off camera. I'm back. So I cut and pasted it. So But instead of 150 students, I have 200 patients. All right, randomly assigned to their groups. All right, instead of 75 students, here I'm going to have 100 patients. All right, in group 1 and group 2. Randomly assigned their treatments. Oh, you know what? I messed up a little bit. Because there are 3 treatments. And here I have a number that's not divisible by 3. I messed up. Okay, the bottom line is I need to have 3 groups, okay? I'll do the best I can to divide these into 3 groups, okay? Yeah. So 200 divided by 3. Alright, since there's 3 treatments, I need 3 groups. 200 is not divisible by 3, so I'm going to go ahead and use the closest number possible. I'm going to use 198 patients. Okay, so, you know, I had 200 patients willing to participate. I'm going to tell 2 of them, thank you for being willing to help us out, but your services will not be necessary. So I'm going to use 198 of these guys. Now 198 divided by 3 is 66. So there will be 66 patients in each group, but I'm going to need a 3rd group. All right, you're going to have the same number of groups as you have treatments. Okay, so group 3. So like I said, this will be 66 patients. Okay, and yeah, so when I do these treatments, I need to have 3 treatments. Okay, I guess I should technically put another arrow in here as well to show the random assignment, okay, to any of these 3 groups. And yeah, I'll need another arrow for this as well. Just tack that on. Yeah, so randomly assigned to any of these 3 treatments. So what do we have? We had chemo therapy. All right, and we had radiation therapy. And we had drug therapy. Okay. And then, so in the end, we're comparing, we're going to compare remission rate. Okay, and again, I'm going to need some extra arrows, I do believe. Well, I'm going to need an extra arrow for my 3rd treatment. Okay, and kabam. Now, oh, you know, I should probably have an extra arrow here. One more extra arrow. Okay, and there you go. This is a nice picture of a completely randomized experiment with 3 treatments, therefore 3 groups. All right, There's one left, but I gotta go to lunch, so I'll have to finish this after my salad and lunch duty. Alright, first of all, here I cleaned this up a little bit, made it look a little nicer. I didn't like the way the arrows were all crooked and asymmetrical, so here's what a lovely, completely randomized experiment looks like when you have 3 treatments and therefore 3 groups. Anyways, now the progress of a type of cancer differs in women and men. So we should examine the data separately. Design a block experiment. Let me underline that. Design a block experiment to compare 3 treatments for this cancer, same as before. And we still want to check out the remission rates, right? So basically we're doing the same thing, only with block. Yeah. I still might have to change the number of patients that I'm dealing with. Let me pause and think about that. You know what, I can see that it'll work because it'll be half of these, so 66, 66, 66 will become 33, 33, 33. So we're good, we're good. Everybody calm down. Anyway, so we're doing block. So one of the main things I want you to see is the way that when I go from comparing a completely randomized experiment with a block design, watch how I cut and paste the entire block. I mean, you know, the entire experiment, really. Okay, so I can start with that. In fact, the deal is we're basically going to be running this experiment twice simultaneously, once for women and once for men. So as I'm cutting and pasting, I might as well cut and paste it again. Okay, because I'm going to need one block for men and one block for women. So this is how a block study starts out. It's going to look identical to a completely randomized study. It's just happening twice for 2 different groups that are difficult to compare. You know, they respond differently to the treatment. So it's like apples and oranges, and you want to separate them out. So, you know, half of 198, don't you know? Okay, is obviously 99. So, and then if I take 99 and divide that into 3 groups, that's 33 each. Okay, so I'm gonna do 198 people. Again, if you skipped to this part of the video, the reason why I'm sort of starting with the 198 instead of 200, I needed something that was divisible by 3 because I have 3 treatments. So 198 is the closest I could get. So the idea is this, guys. You don't have to show this, the original source like this. Okay, I'm just going to do it. Maybe I should put it a different color. You don't have to show what I'm showing right now. But I'm just making a point. Okay, when we just had the experiment run one time, all right, with all the patients together, it was 198 patients. But now that we're splitting it up into men and women, okay, it won't be 198 anymore. Half of 198 is 99. So there will be 99 men and there will be 99 women. Okay. So as I look at the experiment that we're going to do with the men, all right, which we just cut and pasted from above, all that's going to change is the numbers. So we have 99 men. So we have 3 different groups because of the 3 different therapies. So if you, as I showed you, if you do 99 divided by 3, that's 33. So group 1 will be 33 men. All right, group 2 will be 33 men. And group 3 will be 33 men. Okay, meanwhile, now the rest of it is unchanged. Okay, the rest of it is exactly the same, so I'm not going to do anything with the rest of it. All I did was change the numbers. Same thing with the women, so 99 women, so all the same thing down here. 33 women. Group 2 will have 33 women. And group 3 will have 33 women. Okay, and the rest of it is all the same. Because of my OCD, obsessive compulsive disorder, I'm going to just tighten this up a bit. Okay, just a bit, because it's bugging me how far apart they are. Okay. Anyway, I really am done. I'm just, you know, like I said, I'm just cleaning this up, the appearance. But as I'm doing this, just study and observe and make sure you understand, because really I'm done. So you can stop watching the video now if you want. And I think that was the last problem, actually. You know, I think I want to leave this one out here, though, so they line up a little bit. I'll just stretch this out. Okay, that's pretty good. Now, I will say you don't have to put the 198 patients out here. If you put it, great. But if you don't, that's also fine. You can just start from here. All right, anyway, that's it. That was the last problem. This is what a block design looks like. I hope this video was helpful. Don't forget, this is part 2 of a video. So that means there's a part 1. And this is a review D. And there was a review C. So you need to watch all of that. And make sure you can do every single problem. Plus, if I were you, I'd go back through the notes and the homework and make sure you can do it all. I will see you on the next video.